Okay, good morning students. This is a continuation class for crystal oscillator. Now we will see the symbol of the crystal oscillator. Symbol. Actually, the symbol of crystal oscillator is like this. These are the electrodes and between which there is the quartz crystal, quartz. And these are the electrodes which are used for metallic contacts. Okay, next we will see the equivalent circuit of crystal oscillator. Equivalent circuit of crystal oscillator consists of a capacitor Cs, an inductor Ls, a resistance Rs, and a capacitor Cp, and this is the impedance provided by the whole crystal. Now what is this Cs, Ls, Rs and Cp? Cs is called the motional capacitance. It depends upon the characteristics of the crystal. Characteristic means the area of the plates, the thickness of the quartz crystal, the elasticity, etc. Next is Ls. Ls is called the motional inductance of the quartz crystal. Now, motional inductance accounts for the mass, the mechanical mass of the crystal. Rs accounts for the ohmic losses. Cp is the electrode plate capacitance, which is used for electrical contacts. So the capacitance provided by that, this one is Cp. Okay, now the crystal oscillator resonates at two frequencies. One is called series resonant frequency and one is called shunt resonant frequency. Shunt and series resonant frequency. Okay, now let us see what is the series and what is the shunt resonance frequency. The series resonant frequency is 1 by 2 pi root over Ls into Cs. These are the motional inductance and capacitance. And the parallel resonant is 1 by 2 pi root over Ls into C equivalent, where C equivalent is equal to, since we have two capacitance, Cs, Cp, Cs plus Cp. So this is the parallel resonant part. Now if we plot a graph between the resonant frequencies and the impedance, what we'll get is, we will see this type of graph. This is the frequency and this is the mod of the impedance. We'll see this kind of graph. As we can see, as the frequency increases, the impedance reduces and it reaches to a minimum point, which is the series resonant frequency. Again, when the frequency increases, the impedance increases and it reaches to this point, it is called the parallel resonant frequency. Again, beyond this, when the frequency increases, the impedance reduces. This portion is capacitive. The impedance is capacitive, and this portion, the impedance is inductive. As we know that capacitance, it is 1 by omega c, frequency is inversely proportional to the impedance. So when the frequency increases, this is capacitive and this is inductive. This is again capacitive. So when the frequency increases, the impedance reduces, since frequency is inversely proportional to the capacitance. When the frequency increases, the impedance also increases. It means XL is equal to omega L, directly proportional to omega. So this part is inductive. Again beyond this is capacitive. Okay, thank you.